Welcome to this site, everyone. I'm your chief architect for today's explainer, and we are running a full-blown high-rise exam construction workshop. Today, we're tackling a massive, high-stakes project, Mastering Cambridge Mathematics Syllabus Section 5.4. We're talking discrete random variables, specifically the binomial distribution, denoted as BNP. Now, if you're gearing up for your Cambridge pathways, IGC, O, AS, or A-levels, you already know this isn't just about crunching numbers. It's about laying down an unshakable thesis foundation and erecting load-bearing mathematical arguments. To put it in perspective, imagine two builders on our site. You've got Alex, who just stacks up a ton of unorganized factual bricks hoping they hold, and then you've got Sam, who focuses entirely on a flashy exterior design but completely forgets the load-bearing sentence structures underneath. Neither of those buildings is going to pass inspection, but by the end of this workshop, yours absolutely will. Everything is going to click.
And we need it to click because principal examiners are actually red flagging this. They've explicitly stated that this is one of the most misunderstood areas in the entire mathematics syllabus. Honestly, that might sound a bit intimidating, but for us, it's literally a golden opportunity. It shows us exactly where other candidates are dropping their marks because of structural cracks. So, we're going to give you the exact framework to avoid those pitfalls, secure maximum marks, and build a response that examiners are absolutely thrilled to read.
Here is our master schematic for today. First, we're unlocking core principles. Second, we'll map out the method mark strategy. Third, we'll go over the top examiner warnings. And fourth, we're mastering critical analysis. Let's start with phase 1, unlocking core principles, or what I like to call the theoretical architecture. Okay, let's dive into this. You simply cannot build a strong mathematical argument without a rock-solid foundation. The Cambridge Assessment Framework totally prioritizes analytical depth over superficial breadth. So, we start with our foundational notation, BNP. This represents a discrete random variable following a binomial distribution. Now, n is the number of trials, and p is the probability of success. But here is the major examiner alert. Candidates consistently mess up the terminology here. They act like our builder Alex, just throwing n and p bricks onto the page without any mortar. The syllabus explicitly demands that you define these terms clearly and precisely before you execute your mathematical models and extended responses. So, define your architecture first. Once your definitions are locked in and the concrete is poured, examiners are going to stress test your framework across 3 distinct cognitive domains: knowledge and understanding, application, and analysis. Top-performing candidates don't just memorize formulas. They build a fully connected conceptual understanding across all 3 of these domains. You have to understand the theory, apply it to the unique dimensions of a word problem, and then analyze the resulting data. It's this exact balance that prevents your building from swaying when the wind blows or, when you face a completely unfamiliar exam context. Now, here's an insider tip straight from the core principles. Think of this as adding steel rebar to your concrete. Reference cross-topic connections. Section 5.4 doesn't exist in a vacuum, right? It relies on precise definitions, causal relationships, and integration with totally different areas of the syllabus. The principal examiner reports make it super clear. Candidates who successfully weld these cross-topic connections together act like they're reinforcing their math with structural steel. They achieve significantly higher marks. Moving on to phase 2, the method mark strategy. This is all about winning points for your process. Let's map this out on our digital grid overlay. In Cambridge Math, your analytical process is honestly just as critical as your final numeric answer. We need to zero in on the exact methodology examiners scan for when awarding method marks. It's a standardized 5-step sequence. 1. Identify the key elements from the prompt. 2. Apply the relevant binomial principles. 3. Execute your analysis with crystal clear working. 4. Verify your results. And 5. Present them in the appropriate format. Now, real quick, site inspection. Pause the blueprint. To fortify your academic foundations and get weekly structural grade upgrades just like this, make sure you subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. Okay, back to the build. When you hit step 3, execute, this is where you might hit an unexpected structural crack mid-paragraph. If you're struggling, step in with the matrix, like the Peel method. Point, evidence, evaluation, link, to weld your evidence directly to your analysis flawlessly. Memorize this 5-step sequence, and you'll harvest method marks even if your final calculation goes slightly off track. And speaking of step 5, we have to talk about presentation conventions. We're talking proper headings, correct terminology, appropriate formats, and clear annotations. This is the exterior cladding of your high-rise. Skipping these strict procedural conventions isn't just a minor issue. Actually, scratch that. It's a structural crack that will cause a massive mark drop. Examiners are treating you like professionals, so ignoring this will cost you incredibly valuable, easy-to-secure points. Plus, practical application during the exam relies heavily on how well you handle data interpretation. It's a simple rhythm. Extract information from given texts and tables, interpret those mathematical relationships, and then, the most crucial part, conclude. Draw evidence-based conclusions. Every step of your working is essentially a physical piece of evidence supporting your final structural conclusion. All right, phase 3, top examiner warnings. Let's learn how to avoid the traps. Time for some live audience diagnostics. I want to play a quick game of identify the flaw. Based on the examiner reports, these are the top 3 structural gaps that cause a total mark drop. Flaw number 1, confusing cause and effect within a multi-stage analysis. Flaw number 2, forgetting to double-check format and presentation, which we just nailed down. And flaw number 3, providing generic answers that are not specific to the context given. You absolutely cannot just write down a memorized definition. You have to tie your math directly back to the specific scenario on the site. Whether the prompt is about testing factory components or rolling dice, your answer must be bolted to that specific context. Finally, phase 4, mastering critical analysis. This is where we build up to the highest tariff questions. To conquer the most complex questions at the top of the tower, you need higher-order evaluative skills. Let's do another stress test. Imagine a complex blueprint graph on your exam paper. You have a 60-second visual countdown timer in your head to extract the primary metric. When doing comparative analysis in 5.4, examiners literally mandate, that you identify both similarities and differences, and you must use comparative connectives to do so. Every single comparison needs to be supported by mathematical evidence to draw valid conclusions. It's not enough to just say, well, this probability is higher. No way. You have to quantify it, prove it, and explain what that difference actually means for the whole structure. At the very highest level, you have to evaluate the quality of your evidence. This requires identifying limitations in the binomial model itself. You have to call out the assumptions you've made, like, assuming all trials are completely independent, and you need to consider alternative interpretations. Then explicitly state how those factors affect your final conclusions. By evaluating alternatives and providing justified recommendations, you are engineering a flawless analytical response. That is how your paper survives the most rigorous marker reviews. So, we have covered a massive amount of structural ground today, from the pure BNP definitions all the way to avoiding those top examiner traps. Now I have a final challenge for you before we wrap up our inspection. Think back to our 5-step method sequence. Identify, apply, execute, verify, present. What is your custom 5-letter mnemonic for those steps? I want you to create a memory hack right now, using the first letters of those procedural terms. Write it down, use it so you can recall this blueprint perfectly on test day. Remember, knowledge without application is literally just a blueprint without a building. Take what you've learned from our workshop today and immediately go stress test these concepts on real past paper questions. As your final step, make sure to subscribe to AC Exams at AC Exams, click that notification bell, and leave a comment below with your specific subject and level. Keep fortifying those academic foundations, and I will see you on the site for our next masterclass.